Solving a linear system means to find the point of intersection of the two equations in the system. That could be done by graphing both equations on the same grid to visually see where the two lines intersect. You could also solve a linear system using algebraic methods, one of which we talked about in a previous video, which was substitution. In today's lesson, we're going to look at elimination, which is another method that can be used to solve linear systems. It involves adding and subtracting equations to eliminate a variable. So in this first example, we've got two linear equations. They happen to be in the form y equals mx plus b. The first thing I'm going to do is number my equations, number 1 and number 2. What's a little bit different with elimination, or the elimination method, is how we set up our equations. So what we want to do is rewrite our equations, and we're going to stack them one on top of the other. So I'm just going to take equation 1 and then put equation number 2 underneath it. So the point of elimination is to eliminate or get rid of one of the variables. So either the x variable or the y variable, because remember, we can only solve an equation for one variable at a time. So what we're going to do now is we're going to look at our equations and try to figure out which variable would be the easiest to eliminate. So I'm going to start with my x's. And I have them stacked one on top of the other. So if I compare the coefficients in front of the x's, I can see that in the first equation there's a 3 in front of the x, and in the second equation there is a 5 in front of the x. So they are not the same values. It would be much easier to get rid of my x terms if those numbers were identical. So as of right now, the x's aren't the best to work with. In later examples, we will talk about what happens or what we should do if those numbers in front of our variables are not the same. How can we then eliminate them? But for right now, we're going to keep it simple, and we're going to say that we are not going to choose to get rid of the x's just right now. Instead, let's take a look at the y's. So in the first equation, we have just the letter y here. Remember, we know in math, if we don't see a number, we know that there is a number 1 in front of the y. And in the second equation, I also have just the letter y. There is nothing in front of it. We know that there is a 1 there, but for now we're just going to ignore that there is a 1 there, and we just know that there is a y in the first equation and a y in the second equation. So we see the same thing showing up in both equations, and so this is going to be our chosen variable to eliminate. So now that we've decided to work with the y terms, we need to figure out what operation we're going to use in order to eliminate or get rid of those two letter y's that we see in our equations. So our options, we've got two. We could either add the y's together, or we could subtract the y's from each other. So let's kind of go through these options and see what would work best. So if I chose to add my two equations together, then what I would be saying is that I want to take y in the first equation and I want to add it to the y in the second equation. Well, from what I know about collecting like terms, y plus another y would actually give me a 2y. And that's not what I want. I want to actually eliminate or get rid of those y's. So adding is not going to work because adding is just going to generate 2y, and that's not what I want. What if instead we tried to subtract the two equations from each other? So now this is going to read as y minus y. Well, 1y minus 1y is going to be 0. And that's what we want. We want to eliminate or get rid of one of our variables, and we happen to choose the letter y. So we know that subtracting is going to be the operation that works to allow us to get rid of the y variables in both equations. So we've got a 0, then we're going to recopy the equal sign, and then we're going to use the same subtraction operation and apply it to the other terms in our equation. So let's move on to the next terms in the equation, which are the x terms. So we're going to start with the top equation, and we've got a 3x. So we're going to do 3x minus 5x. So 3x minus 5x is a negative, let me just fix that, is a negative 2x. And then we'll move to the last terms. We've got a negative 1. Remember to pay attention to the sign in front of the number. So this actually reads as negative 1. So negative 1 minus 2, which would be negative 3. So now we've generated an equation where there is only one variable that we have to solve for. And this is a simple two-step equation that we know how to solve. We know we need to separate our terms with variables from our plain values or plain numbers. So what I'm going to choose to do is I'm going to take this negative 2x and I'm going to bring it over to the left-hand side. You could totally choose to move the negative 3 to the left-hand side if you wanted to, but it doesn't matter, you're still going to get the same answer. So that's going to leave me with 0 plus 2x, which is equal to negative 3. 0 plus 2x is a positive 2x. And then I want to isolate for x, so I'm going to divide both sides by 2. So my x is going to be equal to negative 3 over 2. So remember, if your fraction cannot be reduced or divide out nicely, you're just going to leave your answer in a fraction form. So my x value is going to be negative 3 over 2. So same like we saw when we used substitution, once you solve for one variable, you need to go back and solve for the second variable or the second half of your point of intersection. So it is your choice. You can choose to take your x value and you can substitute it back into equation number 1 or into equation number 2. Doesn't matter which you choose, you will get exactly the same answer at the end. So what I'm going to do is I'm going to substitute x into equation number 1. So equation number 1 was y equals 3x minus 1. And in the place of x, I'm going to put in my number, which is negative 3 over 2. All right, so we're going to now do the multiplication. We've got 3 multiplied by negative 3 over 2. And again, use your calculator if you are not comfortable with using fractions. And remember, your fractions should always be kept as improper fractions. So 3 times negative 3 over 2 is negative 9 over 2. And then from there, we're going to do negative 9 over 2 subtracted by 1. And so my final answer for y works out to be negative 11 over 2. Okay, so I can then write my conclusion and say, therefore, the point of intersection is negative 3 over 2 and negative 11 over 2. All right, let's take a look at our second example. I've gone ahead and numbered off my equations with numbers 1 and 2. The next thing we want to do is we want to rewrite the equations and we want to stack them on top of each other. When you are stacking your equations, you also want to make sure that you are lining up the same or matching variables and terms. So for example, you want your x's to be stacked on top of each other, you want your y terms to be stacked on top of each other, you want your equal signs to line up as well, and you want the plain or constant terms to stack up or line up on top of each other as well. So I'm going to put in my bar. Okay. And now we're going to decide which variable is going to be the easiest or the simplest to eliminate. So I'm going to start with looking at my x values. In the first equation, we've got a 2x. In the second equation, we have just an x. So these are not the same coefficients in front of the x. The first one has a 2. The second one just has a 1 here. Even though we don't see it, we know there's a 1. These are not the same numbers. So it's not going to be very straightforward to try to eliminate the x terms. So we're not going to focus on using the x's. Let's instead look over at the y terms. So in the first equation, we've got a 3y. And in the second equation, we also have a 3y. So these are the same coefficients in front of the y. So we're going to focus on trying to eliminate the y term again in this equation. The next thing we want to pay attention to is the signs in front of those 3's. So in the first equation, there is a positive 3. But in the second equation, there is a negative 3. So what we need to be careful with is deciding which operation we're going to use to eliminate our y. So is it going to be addition, or is it going to be a subtraction? So we just kind of have to play around with the numbers and do a little bit of mental math and figure out which operation is going to give us an answer of 0. So I'm just going to do some math on the side here. What if we tried subtraction? So we used subtraction in the first example. So let's try subtraction again and see if it works out for us. So we have a positive 3 in the first equation minus a negative 3 in the second equation. So again, like what I always say to you, be careful with your signs and how you read the numbers. This is a negative 3. So if we do 3 minus negative 3, that actually equals 6. It doesn't equal 0 like we want it to. So it's not going to get eliminated out of the linear system if we try using subtraction. So let's erase that. And instead, let's try using addition. So instead of a subtraction, let's do 3 plus negative 3. Well, 3 plus negative 3 is the same thing as saying 3 minus 3, and that would actually work out to be 0. So addition is going to have to be the operation that we use for this particular system of equations. So I'm just going to erase all of this off my screen. I'm going to erase the subtraction, and we are choosing to go with addition for this particular system. So we're going to start on the far left, and we're actually going to start with our x terms because they show up first. So this is 2x plus x. So 2x plus x is 3x. And then we have our 3y plus negative 3y. That is a 0. So we could say a plus 0. And then we have our equal sign. And then we have 15 plus 3. 15 plus 3 is 18. All right, so I'm just going to simplify this to 3x equals 18. We can leave out the 0 because we know there's no value there. And then we just need to isolate for x. So to isolate for x, I'm going to divide both sides by 3. So x is going to give me 6. So there's my x value. And then, like before, it is your choice. You could take your x value and substitute it back into equation number 1 or equation number 2. So just to be different, I'm going to choose this time to substitute x into equation number 2. So what is equation number 2? Equation number 2 is x minus 3y equals 3. So in the place of x, I'm going to put in my answer of 6. Okay, I'm going to collect like terms. So I'm going to take this positive 6 and bring it over to the right-hand side. So that's going to leave me with negative 3y equals 3 minus 6. Okay, 3 minus 6 is negative 3. And then to isolate for y, I need to divide both sides by negative 3. So my y value is going to work out to be a positive 1. So therefore, my point of intersection is located at 6 and 1. So here we have another example. I've numbered my equations as number 1 and number 2, and I've rewritten them and stacked them on top of each other. So now when we actually look and compare our x's and y's to each other, we see that there are different numbers or values in front of each variable. So in the first equation, there is a 4 in front of the x, but in the second equation, there's a 3 in front of the x. So we've got mismatched values for our x's. And then when we look at the y's, we've got a 2 in front of the y in the first equation, and we've got a 4 in front of the y in the second equation. So we've got mismatched values for our y variables as well. So there isn't something that is straightforward to our eye that shows us that we could very easily eliminate it. So when you've got mismatched values like so, we need to add in an extra step. And what that step is we need to multiply one or both equations by a number that will change these values into the same number. So I'm going to choose to work with my x terms. You could totally choose to work with the y terms, doesn't matter. You want to work though with terms that are going to have a nice easy value to multiply by. Try to avoid having to multiply by decimal values because it's just going to make the math more complicated later on. And remember, we don't really like to work with fractions when we're solving equations. So try to avoid multiplying by decimals because that's just going to generate more fractions later on. So I'm going to choose to focus on my x values. So the numbers that I'm going to work with are 4 and 3. So I need to think of a number that they can both multiply into. And so I know that both of those numbers can multiply to give 12. So with the first equation, I know that if I take 4 and multiply it by 3, that will give me 12. And with my second equation, I know that if I take 3 and multiply it by 4, that will also generate 12. So those are going to be my multiplying factors. But remember in math, whatever you do to one term, you must do to all of the terms. So in the first equation, I chose to multiply 4 with 3, but that means that everything in the first equation has to get multiplied by 3. And in my second equation, I chose to multiply by 4, but that means that everything in the second equation has to get multiplied by 4. So let's go ahead and do that multiplication. So we'll start with the first equation. We've got 4x multiplied by 3, which is 12x. Then we've got 2y multiplied by 3, which is a positive 6y. We have our equal sign, and then we've got 5 multiplied by 3, which is 15. In our second equation, we've got 3x multiplied by 4, which is 12x. Then we have 4y multiplied by 4, which is a positive 16y. We have an equal sign. And then we've got 7 multiplied by 4, which is 28. I'm going to put in another bar here. So now we have a brand new system of equations. Okay, they are still the same equations that we started with at the very beginning. They've just been increased or multiplied by a factor. So now when we look at our equations and we focus specifically on our x terms, because that's what we chose to work with, we see that we've got a 12x and a 12x. So we've got matching terms that are going to be very simple to eliminate. So now it's just a matter of figuring out which operation are we going to use to eliminate our x terms. Are we going to add the two terms together, or are we going to subtract the two terms together? Well, using mental math, I know that I can't use addition because a 12x plus a 12x is going to give me 24x, and that's not what I want. I want to get rid of the terms. So instead of adding, we are actually going to subtract, because I know that 12x minus 12x is going to give me 0, and that's going to get rid of these x terms from our linear system. So we're going to follow through now, and we're going to subtract the remainder of the terms in the question. So we've got 6y minus 16y. and that will give us negative 10y. We have our equal sign, and then we have 15 minus 28, which will give us a negative 13. So we want to isolate for y, so I'm going to divide both sides by negative 10. And I know that 13 over 10 isn't going to divide nicely, so it's not going to be a nice decimal answer that I can use, and 13 over 10 is not going to reduce down any further. I also know that when I have two negatives, that is going to make a positive. So my final answer is going to be 13 over 10. So not the nicest of fractions, but it is what it works out to. So this y value is now going to go back into either equation number 1 or equation number 2. So I've chosen to substitute y into equation number 1, so I've recopied equation number 1 onto the screen, and now I'm going to go ahead and substitute my y value in its proper place. Okay, so I've got 4x plus, well, 2 times 13 over 10. If I keep it as an improper fraction, it's going to give me 13 over 5. So that is the simplified reduced answer that I get when I do that multiplication in my calculator. And that is all equal to 5. So 13 over 5 is not a pretty fraction. So what I'm going to choose to do is get rid of the fraction and try to make the math in the rest of the solution more simple. So there is a 5 in my fraction denominator. So everything in my equation is going to get multiplied by 5. So 5 times 4x is 20x. 13 over 5 multiplied by 5 is 13. And 5 times 5 is 25. So now we've got something that looks much more easier to work with. So I'm going to collect like terms. So I'm going to bring this positive 13 to the right-hand side. That's going to leave me with 20x equals 25 minus 13. 25 minus 13 is 12. And then to isolate for x, I'm going to divide both sides by 20. 12 over 20 is not going to divide out nicely. However, 12 over 20 can be reduced, and it reduces down to 3 over 5. So this is my answer for x. So when you are writing your final therefore statement and you are stating your point of intersection, remember to put your numbers in the correct order. The first value needs to be your x value. The second value needs to be your y value. So my x value was 3 over 5, and my y value, I believe, was 13 over 10. So my point of intersection is located at 3 over 5 and 13 over 10. And now it's your turn. Here are two brand new equations in a linear system. You are going to try to use the elimination method to solve for the point of intersection. So go ahead, pause the video, see if you can try to solve it on your own, and then come back and hit play when you've gotten an answer. So you should number off your equations and stack them one on top of the other as shown on the screen. And really it's your choice. You can choose to try to eliminate the x's or choose to try to eliminate the y variables. As you can see, there are different coefficients in front of both the x's and the y's. So we are going to have to do a little bit of multiplying with this particular system. Since we worked with x's in the previous example, I'm just going to choose to work with the y's in this one just to change it up a little bit. So in my first equation, I see that there is a negative 4 in front of the y. or just actually a 4. Let's just focus on the number, not the sign. So there is a 4 in front of the y, and in the second equation, there is a 2 in front of the y. So I know that 4 and 2 are really nice, easy numbers to work with. And I know that if I take my second equation and I multiply this 2 by 2, I can turn it into 4. And then the y's will have matching numbers. They will both be a 4y. So if I choose to multiply my 2y by 2, well, that means everything in the second equation has to be multiplied by 2. The first equation, however, it's already at a 4y. It doesn't need to be multiplied by anything, so I'm just going to leave this first equation exactly the same. Now, sometimes students will kind of miss the obvious, that 2 is a multiple of 4, and instead they'll say to themselves, well, I know that both 4 and 2 are multiples of 8. And what they will do is they will use the multiplication and they will turn the 4y into an 8y, and they will turn the 2y into an 8y by multiplying by the correct factor. That's totally okay. It's going to give you the exact same answer in the end, but I figure why create extra work for ourselves and multiply both equations when really we only have to multiply one equation in this particular example. So I'm just going to leave it as is. So I'm going to recopy the first equation since I did nothing to it. But in my second equation, everything has to get multiplied by 2. So I'm going to start on the far left here, and I've got a 3x multiplied by 2, which is 6x. And then I have 2y multiplied by 2, which is a positive 4y. I have an equal sign. And then I have 10 multiplied by 2, which is 20. So here is my brand new system of equations. The next thing I want to do is figure out if I'm going to add or subtract these two equations together in order to eliminate my y variable or my y terms. So I've got a negative 4 and a positive 4. So I need to figure out what sign needs to go between them in order to make it equal to 0. So just by using my mental math knowledge, I know that if I add these two numbers together, it's going to give me 0 because negative 4 plus 4 is 0. So that means that in front of my system of equations, I'm going to put a big addition symbol. So if I go ahead and add together my terms, I'm going to start with the 9x. So 9x plus 6x is 15x. I've got negative 4y plus a positive 4y, that is 0. So these terms have been eliminated. Okay, I've got my equal sign, and then I have a positive 10 plus 20, which is 30. So I've got 15x equals 30. And to isolate for x, I'm going to divide both sides by 15. So that's going to leave me with x equals 2. Now that I have my answer for x, I've chosen to substitute it back into equation number 1, which I've recopied onto my page. So I'm going to substitute in the place of x 2. Okay, 9 times 2 is 18. I'm going to recopy the rest. Now I'm going to go ahead and collect like terms. So I'm going to take this 18 and bring it over to the right-hand side. That's going to leave me with negative 4y equals 10 minus 18. So we've got negative 4y equals negative 8. 10 minus 18 is negative 8. And then to isolate for y, I need to divide both sides by negative 4. So that's going to leave me with an answer of y equals positive 2. So my final conclusion then is therefore my point of intersection is located at 2 and 2.